Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 6 in the cross-site scripting module titled DOM XSS in jQuery selector sync using a hashchange event. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portswigger.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy. Select all labs, do a search on cross-site scripting labs, and go to lab number 6, titled DOM XSS in jQuery selector, sync using a hashchange event. Alright, let's get started. This lab contains a DOM-based cross-site scripting vulnerability on the home page. It uses jQuery selector function to auto-scroll to a given post whose title is passed via the location.hash property. To solve the lab, deliver an exploit to the victim that calls the print function in their browser. Alright, so the target goal over here is to exploit the DOM-based XSS vulnerability to call the print function in the victim user's browser. Let's access the lab. Now notice over here, this is the built-in browser in Burp, and so all my requests are already being passed in my Burp proxy. When it comes to DOM-based XSS vulnerabilities, I don't really use the proxy. Instead, I use the developer tools in the browser. So for this lab, we won't be using the proxy and we'll just be using the browser. So usually what we do is we map the application and see if any of the parameters could potentially be vulnerable to XSS. The way to do that is by putting in a string in the parameter that you think might be vulnerable and see if it's reflected back to the user or potentially even interacting with the document object model. And so what we're going to do over here is first right click and then view page source and then look for any JavaScript that could potentially be taking client supplied input. And you can see over here we've got some JavaScript. If we scroll to the right, you could see that on the hashchange event, so this is an event that is fired when the fragment identifier of the URL has changed. So when I say fragment identifier, that would be the part that is beginning and after the hash sign. So it would be hash, and then everything after the hash sign would be the fragment identifier. Now, the hashchange event is triggered if this value over here changes. So when there is a change to that value, what it does is it essentially runs this entire thing right over here, which takes in the section tag. So if we go right over here, you could see it's this tag right over here, and it's looking for blog list. So this class right over here, and then it's looking for the h2 element. So if we go to the h2 element, this is what it's looking for. So either this h2 element, or this h2 element, or this h2 element, and so on. And then it's running this function right over here. So decode URI component window.location.hash.slice1. Essentially what this does is it splits the URL to everything that is after the hash sign, and then it outputs it, saves it in post, and then if post is not empty, it essentially scrolls to that value. So if you go back over here, the legitimate use of this functionality is to be able to scroll to a certain blog, and it's based on the headings, so the h2 element. So you can see over here, there's the cool parent, there is tracking your kids, there is what can 5G do for you, and then there is don't believe everything you read, and so on. So if we just copy, let's say the second one, so tracking your kids, go over here and put it after the hash sign, what should happen is this function should run. It should slice up my URL into just this one right over here and go to that specific link in the page. So let's hit enter. And here we go. You could see that it automatically scrolled down to this article over here. Now, if you want to confirm that that's what it's doing, all you could do is just like copy this. Go over here, right click, inspect, go to your console, put it in here, and then hit enter, and you could see what this piece of code is responsible for is really just slicing up the URL or segmenting the URL into whatever is after the hash sign. All right, So how could this be vulnerable? Well, whatever is after the hash sign is client controllable, and then it is being used in order to redirect the user to another page in the application. So the lab over here wants us to call the print function. So all we have to do is really insert our malicious JavaScript after the hash sign right over here. So the malicious JavaScript will be using an image tag. We'll say the source is equal to anything. In this case, we'll just say 1. And when it doesn't find this source for this image tag, it'll error out. And on error, I wanted to call the print function. So let's copy this, put it in here. So after the hash sign, now again, once I hit enter, it'll trigger the script right over here, and then it'll execute my malicious payload. So let's hit enter right over here. And here we go. You get presented with the print functionality. Let's click cancel. And if we go down right over here, you could see that we didn't get the congratulations, you solved the lab message. And the reason is because this function over here only triggers when there's a change to the hash function. So let's imagine this is a real world scenario when you copy this entire URL and send it to the user. What'll happen is when the user clicks on that link, so let's actually do that right over here. So this is a new browser. The user enters, and the user is not presented with the print function. And the reason the user is not presented with the print function is because the script is only triggered when there's a change in the URL. And when you send the user this URL right over here, this was the original URL, and it would have to change for that script to run. So what we're going to do instead is we're going to put this application in an iframe where it only has the hash sign right over here and nothing after it. And then we're going to use the source attribute of the iframe to dynamically change the URL to include our payload right over here. And so when the user loads it up in their browser, what'll happen is it'll first load on this URL over here, and then it'll change the source attribute to include our print function. Since there's a change in the URL, it'll trigger this function over here, and we should be able to complete the exercise. So to do that, we're going to use the exploit server over here, which is just an attacker-controlled server. And the first thing we're going to do is see if we could even frame this application. Now, most applications won't allow for framing because it can be used in clickjacking attacks. So to frame an element, we'll just say the source is equal to the URL of the application, which is just this right over here. Let's copy this and put it in here and remove everything after the hash sign. So this is what will get loaded in the user's browser. Let's click on View Exploit. And perfect. So you could see over here, this is my iframe, and I've got the application in my iframe. Now, this is what will load in the user's browser when the user clicks on the malicious website, which would be this one right over here. Now, what I want to do is after it loads this URL over here, I want to change the URL to include my malicious payload. And since it is a change in the URL, it'll trigger the script that is vulnerable to DOM-based XSS. So in this case, I'll say onload. So after it's loaded, this .src is equal to the image tag. And src, again, we said is equal to 1. It could be anything. On error is equal to print. And that's essentially it. This looks good. So essentially over here, again, the reason this would work is because first it'll load this URL over here, and then it'll change the URL to include this payload over here after the hash sign. And so since there is a change, the hash change event will be triggered, which will trigger the piece of code that is responsible for exploiting our DOM-based XSS. So let's deliver the exploit to the victim user. And here we go. We get the congratulations, you solved the lab message because the victim user clicked on the link. So they have an automated robot that clicks on the link. And if the victim user is presented with the print function, that means we completed the exercise. All right, so we successfully completed the exercise by exploiting the DOM-based XSS vulnerability. In the next lab, we'll look at another case of a cross-site scripting vulnerability.